We're all getting pretty used to AI that can write poems, code a website, or even pass the bar exam. But behind the scenes, there's a much quieter revolution going on, and it's about to take AI from being just a clever mimic to something, well, a whole lot more real.
And it all kind of starts with this question. Have you ever been playing with something like ChatGPT and just been blown away by its brilliance, only for it to make a shockingly simple mistake? It can write this beautiful sonnet about quantum physics, but then get totally stumped by a simple riddle. Like, which weighs more, a pound of feathers or a pound of lead? It feels so smart, but it doesn't really get it. It doesn't understand.
And that right there is the crucial difference. The AI we have today is basically a digital parrot. It is fantastic at repeating and remixing all the information it's ever read online. It can tell you all about gravity because it's read a billion textbooks. But this next generation, it's more like an artificial animal. It's not just going to read about gravity, it's going to learn what gravity is by, experiencing its effects, by watching things fall over and over and over again.
So the big question is, how do we get from that parrot to the animal? Well, it's happening right now through two absolutely massive shifts. And these aren't just little software updates. We're talking about fundamental changes to how we build and train AI from the ground up.
The first shift is a complete game changer. For years, we've tried to make AI smarter by just feeding it more data, more text, more books, more of the internet. We were basically giving it a bigger and bigger library to memorize. But now, the focus is completely changing. We're moving away from giving it things to read and toward giving it things to experience.
And that brings us to this first huge idea: AI learning directly from the world. Think about it like this. What's the difference between reading 50 books about how to ride a bike and actually hopping on one and trying to balance? That's the leap we're talking about here. We're going from encyclopedia knowledge to, well, real, embodied understanding.
Okay, so the technical term for this is experiential learning. What it means is, instead of training an AI on a fixed, static pile of text and images we scraped off the internet years ago, you have it build its entire picture of the world from a constant, real-time stream of sensory input, just like an animal does from the second it's born.
And the benefits of doing it this way are huge. An AI that learns like this actually starts to develop common sense, a real intuition for the physical world. It's way less likely to hallucinate or just make stuff up because its knowledge is grounded in things it's actually seen. It gets so much better at handling new situations it's never encountered before. And maybe the most exciting part, it can learn forever, constantly getting smarter just by existing and interacting with the world.
And this isn't science fiction, it's happening right now. Just look at OpenAI's Sora. It wasn't taught physics from some textbook. It built up this incredible, intuitive grasp of things like gravity and momentum and how objects should behave simply by watching millions of random videos and learning to predict what happens next.
We're seeing the exact same idea in self-driving cars. Wayve's model, Gaia 1, learns how to handle really complex traffic situations, not from a programmer's rulebook, but by building its own model of the world from billions of kilometers of real driving footage. It learns what other drivers are probably going to do because it's seen it happen a million times before.
It works for physical stuff too. Check out Gen, a robotics model from Berkeley. It was trained on, get this, 10 billion video frames of robot arms just messing around, pushing things, picking stuff up, wiggling around. There was zero internet text in its training, none. And yet, from that purely physical experience, it learned how to follow really complex instructions.
Okay, so that's the first huge shift, learning from experience. The second one is just as important. We're ditching the whole idea of building one single, giant, monolithic AI brain that's supposed to do everything. And instead, we're building a whole team of specialists that work together.
Think about it like you're building a company. The old way was like trying to hire one single person to be your CEO, your head of marketing, your accountant, and your engineer all at once. It's just super inefficient and a total nightmare to retrain. The new way, this modular architecture, is like hiring a team of experts. Each one is amazing at their one specific job, and they all collaborate. It's way more efficient, way more powerful, and you can upgrade one part of the team without having to retrain the entire company.
And here's what that team looks like in the AI world. You've got a memory module, like Meta's Cicero, which is brilliant at remembering past conversations or the state of a game. Then you've got a math whiz, like DeepMind's AlphaProof, that can literally solve math problems that stump humans. You've got a physics simulator, like the one inside Gaia, that predicts what'll happen if a car slams on its brakes. And then you have a planning module, which is kind of like the project manager, pulling in the right expert at just the right time to get the job done.
Okay, now I want you to look at this number. Get ready for this. 50 kilobytes.
That's it. That's the total size of one of these specialized AI experts, one that can do a complex task like recognizing a person in an image. These expert modules don't have to be massive. They can be incredibly tiny and hyper-efficient. I mean, literally smaller than a single photo you took on your phone. This is what makes the whole system so much faster, cheaper, and easier to scale.
So you have all these tiny, super efficient specialists. But how in the world do you get them to work together as a coherent team when there's no single boss telling them what to do? Well, the solution, amazingly enough, comes directly from nature. It comes from the ant colony.
Right, an ant colony is this perfect example of decentralized intelligence. No single ant is in charge. It all works because of a few simple rules. An ant stumbles upon some food, and on its way back to the nest, it leaves a little chemical trail. Other ants are just programmed to follow the strongest chemical trail they can find, which naturally reinforces the best and shortest path to the food. Simple rules leading to incredibly complex, intelligent behavior.
And this is exactly how this new modular AI works. When a problem comes in, all the different specialist modules propose their own solutions. The paths that seem the most promising get reinforced with higher probability weights. Those are the digital pheromones. And this simple process guides the entire system, all these little experts, toward the best possible solution, all without any central commander calling the shots. It's what we call emergent intelligence. Okay, so let's bring these two giant shifts together. On one hand, you have AIs that learn from raw experience. On the other, you have AIs that are built from these nimble teams of tiny specialists that coordinate like an ant colony. So, what does that all add up to?
It means the next wave of AI is going to feel a lot more like these artificial animals. They're not going to be these static tools that you just type a question into. They'll be adaptive systems, constantly learning and changing from their interactions with the real world. And because they're grounded in that experience and built from these robust, specialized parts, they're going to have way better common sense and be far more reliable and, frankly, safer than the digital parrots we're using today.
There's this quote from the research that just perfectly sums it all up. We are really at this turning point, moving away from systems that just predict the next word in a sentence and towards systems that actually build a real model of the world based on what they've seen and done.
Which, of course, leaves us with one last, really fascinating question to think about. Once we have AI that doesn't just know a bunch of facts, but actually understands the world through its own experience, an AI with real common sense, what are the very first problems we should ask it to solve?